steam rate actually. So that is your spreader stroker. Mm, then I have shown you the diagram for the chain gauge stroker. Then we are having the spreader stroker. So where that supply of the coal will be uniformly distributed with the help of the spreader over the bed of the uh, grate. And here in this case, we can burn the any type of coal. Okay, so from the low quality to high quality type of coal. Okay, so here the boiler capacity will range from 70,000 kg to 1,40,000 kg of steam per hour, and heat release rate is about this much. And this is mostly suitable for the fluctuating load, and which can easily meet that load. So this is the about the spreader stroker. Then we are having the underfeed stroker. So under this, um, in this case, the air and the fuel will move in the same direction. Okay, so that is your underfeed stroker. So in this type of stroker, we can burn the semi-bituminous and bituminous coal. And this type of stokers are mainly suitable for the non-clinkering and high volatile coals, having the caking properties and low ash contents. Okay, so in this type of stroker, we will get the high thermal efficiency. So it will require the large building space and low grade fuels with a high ash content cannot be burnt economically. Okay, so as it is the design for the low ash content. So if you observe this diagram, the air will enter from the bottom side. So here the hole will be given, primary hole will be there through which the air will pass. So that will be passed through the grate. So this is the grate arrangement. Then it will come in contact with the uh, raw raw coal, or else it is also known as the green coal. So here there will be the due to the uh, mm, availability of the oxygen that will burn, and after that that air will pass through the incandescent. This is the incandescent coke, and mm, then it will pass to the ash, where there will be the different gas will be separate out, and over this one, if you are supplying the secondary air, then you can get the burning of the combustion product. So here that secondary air is provided to burn the combustible gases. So here that flame will be generated. Okay. So in this case, that supply of the secondary air can be controlled by the distributing lamp mechanism, which is the mechanical type. Okay, so this is all about your underfeed stokers. So as I've already told you, it is having the high thermal efficiency, and the combustion rate is more as compared to your overfeed stoker. Okay, so here in this case, the grate will be the self cleaning itself. So in this case, the part load efficiency. Okay. So here also we can use the different varieties of coals. Okay, so high steam rate generation will be there. In this case, the gas will be the smokeless. It is having the disadvantages also. Disadvantages means here it will require the large space, and another one is the high initial cost will be there in this case. So in this case, the clinkering, as we are using it is preferable for the non-clinkering type of coal. So if you are using a different kind of coal, so here you may experience the clinkering troubles. Okay. So another drawback is that as here we have mentioned, we cannot use the high as content kind of fuel. So these are the disadvantages of the underfeed stoker. Then we will discuss the pulverized fuel pairing system. As the name is given pulverized, pulverized means it is the powder form of the coal. So in this case, a pulverized fuel firing system, coal is reduced to a fine powder with the help of grinding mill. Then it will be projected into the combustion chamber with the help of the hot air current. Okay, okay. So the amount of air which is used to carry the coal and to dry it before entering in to the combustion chamber is known as the primary air. So if you are observing this one, so this is the supply of your coal with the help of the hot air. So here the burner like structure will be used, which can supply the air with the flame arrangement. So here another secondary air duct will be present through which we can supply the secondary air which will help to burn the coal. Okay, the fineness of the coal in this case should be such as 70% of it would be passed through the 200 mesh sieve and 90% through 50 mesh sieve. So there are the different size of the sieve. So as per the size of the sieve, that percentage of the coal will be supplied in this case. So it is possible to use highly preheated secondary air that is about 350 degrees Celsius, which helps for rapid flame propagation. So here, if you are observing, this is the rapid flame propagation. So it is the entry point, then it is propagating like the cone structure. So that flame will be rapidly propagate if the preheated air temperature is used around 350 degrees Celsius. So lots of fly ash in the form of fine dust removal is uneconomical in this case. High furnace temperature cause rapid deterioration of refractory surface as there is the movement of the flame is rapid one. So in that case there will be the rapid deterioration due to the temperature fluctuation in the refractory surface. So sometimes the grinding of the fuel to the fine size and distribution through a burner is difficult. So as the main coal size is mentioned as per the sieve size, sometimes it is difficult also. We because of which so we cannot distribute the coal properly through the burner. So this is about your pulverized fuel pairing system. Under this, we can use the many fuel handling system. Uh, uh, so under this pulverized fuel system, fuel handling system. So pulverized fuel handling system that can be of the uh, mm, two main types. One is the unit system, another one is the central system. So unit system is nowadays it is installed in many pulverized industrial uh, pulverized supply system. So in this case, you will have the supply of the primary air. Okay, so there are the separators. So separators are used to separate the different size of the coal. So then that will be fed to the chamber with the help of the fan, and chamber means to the furnace. Okay, so with the high pressure fan, then it will go to the burner, and then it will go to the furnace. So in this case, we will also use the preheated secondary air. Okay, so this is about the unit system. So then we are having the central system. So central system means in this case there will be the pulverizer mills from which there will be the direct supply of the coal to the burner, and there will be the primary fan only used here. We do not have any secondary air. Yeah. Okay, so that is your central system. Central system means here that directly the coal will be supplied of the different size to the burner. In this case, we will use only the primary here. So there are the different pulverizers are available. Okay, so as per these coal pulverizers, so there are the two types of mills available. So two types of mills means one is the attrition. So under this we are having the two types. One is the ball and race mills, bow mills. Then we are having the impact mills. Under this we are having the ball mills. Another one is the hammer mills. Okay. So these are the different types of pulverizers. Mainly we are using in the pulverizer mills. Under this we are having the two types of mills. One is the attrition mill, another one is the impact mill. So I'm not going to the details of this type of ball mills and bow mills, and another one is the hammer mills. Okay. So directly we will discuss the burners.
मैम
Oh, बोलो.
मैम यूनिट और सेंट्रल सिस्टम में बेटर कौन सा होगा?
बेटर तो यूनिट सिस्टम ही होती है. यहाँ पे प्रॉपर कंबशन होती है. Because
लेकिन
of
मैम
this
पावर
primary
इनपुट भी
air
तो ज्यादा
supply.
होगा ना
हाँ,
यूनिट
प्राइमरी
सिस्टम.
यूनिट ज़्यादा होगा, बट यहाँ पे जो कोल का लॉसेस है वो रिड्यूस हो जाएगा. यहाँ पे और एक चीज़ है, मेंटेनेंस चार्ज आपका कम होगा, बिकॉज इट इज चीपर देन द सेंट्रल सिस्टम. तो
यस
यहाँ
मैम.
पे क्या होगा आपका, कॉम्प्लेक्स ट्रांसपोर्टेशन सिस्टम नहीं रहेगा, जैसे कि पल्वराइजर मिल से हम लोग भेज रहे हैं, है ना?
Yes,
Got
ma'am.
my point? Okay. Next one is your burners. So burners are used in case of the pulverized fuel firing system. So there is the pulverized fuel burners. Another one is the oil burners and gas burners. So pulverized fuel burners are used for the solid fuel. That is your coal. So coal are of different size as per the different shape size. Then we are having the oil burners. So oil burners are used in case of the liquid fuel if you are using the diesel fuel. Okay. So then we are having the gas burners. Gas burners are used if you are using any gas like your natural gas or LPG gas or natural. Under this natural gas we are having the methane gas, LPG, CNG. So in that case you are using the gas burners. Okay. So now I'm going to discuss about the pulverized fuel burners. So in this case, pulverized fuel burners. So there are of the different types. One is the long flame burners. Another one is the turbulent burners, tangential burners, and cyclone burners. So long flame burners means so here you will have the U-type structure. So if you are observing in this case, the primary air uh, with the particular temperature along with air will fed to the furnace, and there is the tertiary air will be provided through there that at the entry point there it will get at entry point that flame will be become widened due to the availability of the oxygen. Okay, so this tertiary air will form an envelope around the primary air. Okay, so which will provide the better mixing. So due to this better mixing, there the flame will be travel in such a way that the flame area will become wider one. Okay. So in this case, we are using the low volatile type of fuel. That is your coal. So which can give you the long flame structure, and the burning will be the little bit slower. So here another side we are providing the secondary air so that the path of the flames would be the longer one. Okay. Mm, so here that one only I have written. U flame or streamlined burners are used in this case. Furnace for low volatile coal are equipped with such burners to give a long flame path for slow were burning particles. Okay, so that is all about your long flame burners. Then we are going to discuss the turbulent burners. As the name is given turbulent, so the flame will propagate haphazardly, and velocity is high in this case. So in this case, the flame will be shorter than the previous one. So generally, in this case, short flame burners are used and can fire horizontally or at some inclination by adjustment. So in this case, the firing will be the horizontal. As you can see, it is the horizontal, or it may be some inclination like this. Okay, so which can be adjusted by mechanically. So it will provide high rate of combustion compared with other types as the turbulent movement. So generally preferred for high it is preferred. So it is preferred for high volatile coal. All model power plants are using this type of turbulent burners. So due to the high turbulence created before entering the furnace, the mixture will burn intensively inside this combustion chamber or furnace, due to which we can get the complete combustion and within the certain distance, and we will get the short run. Got my point. So this one is the turbulent burner. Then, so these are for the solid fuel I'm discussing. Then it is a tangential burner. So as the name is given, tangential burners, the burners are placed tangentially to the, it is the furnace. Okay, so suppose the furnace is in the square form, and that's burners are placed tangential to the different corners. So four burners are located, four burners of the furnace, fired in such a way that the four flames are tangential to an imaginary circle will form at the center. Okay, so here the high circulation of air and fuel will achieve. So primary air along with fuel will be given through this one. Again, at this entry point, we are providing the secondary air so that it will provide the better mixing of the air fuel mixture, as well as it is a preheated air, so that here at the center you can get the complete combustion. Okay, so in this case, it has having the following. It has having the different advantage. So in this case, the burners are well protected by the wall tubes of the furnace. So here it is, as per the safety aspect, it is well protected. The In this case, the operation is also simple. In this case, as at the center, it is creating the cyclone or turbulent. So here you can get the high heat release with a complete combustion. Okay. So the in this case, this arrangement can be used for the liquid fuel also. Also, you can use the gaseous fuel. Okay, so liquid, gaseous, and pulverized fuels can be readily used in this type of burners. So, uh, a, uh, this is about your tangential burner. Then it is the cyclone burners. As the cyclone name is given cyclone. In this case, the burners will create the uh, circulation of the hot and primary air in such a way that the air movement is rapid in this case, and due to which it will generate a cyclone type of combustion within the cylinder. So in here, um, uh, why we are using the cyclone burners? Here we are having the two main disadvantages of the pulverized firing system. One is the high cost, another is the requirement of expensive dust collectors for collection of dust, as 70% of us escape as the fly ash. So that's why we are referring cyclone burners. The coal is crossed to a maximum size of 6 mm in this case and blows into a cylindrical cyclone burner. Okay, so here at the end, it is the cylindrical furnace. So entry is given. The front view is given like this. So the primary and red hot air will be given to the uh, um, furnace tangentially, so that it can create a circular movement. So here we are providing the, at the center we are providing the tertiary air, so that here it can provide the cyclone movement of the air and fuel. So at the another point, we are supplying the secondary air to facilitate the combustion process. Okay, so it will provide the uh, mm, uh, top, it will provide the hot gases, and at the bottom there will be the molten ash will be collected, and at the end of the cylindrical furnace, that molten ash will be collected at one point. Okay, so because of that one, there will be not the ash will not escape along with the fly ash or hot gases. So secondary air enters the furnace through the tangential port in this case if you are observing. So this is at the upper edge with the high speed and high heat liberation rate will be achieved due to this. So because of this one, tangential is applied, so vertex will be created, turbulent vertex will be created because of that one. There, air movement will, air speed will be increased. So in this case, the high temperature you can get that high temperature of the gases will be about 2000 degree Celsius. Okay, so this is the cyclone burner. So in this case, we can get the high furnace temperature. Okay, so in this case, simplified coal with the existing equipment uh, can be used without pulverized mills. Okay. So in this case, the air supply is little bit lesser than the previous types of burner, and this can burn the proper means low quality and um, the size different size of the coal, uh, which is in the pulverized form. Okay. So in this case, boiler efficiency will increase as the temperature is increased, right? So in this case, the cost of milling in cyclone fire is less as compared to the other types. So these are your advantages. Then we are going to discuss the oil burners. So oil burners are classified into the different categories. One is the vaporizing oil burners. Another one is the atomizing fuel burners. Okay. So vaporizing oil furnace, oil burner.
मैम
Uh,
मैम जो कोल बर्नर्स थे वो कंटिन्यूअसली काम करते हैं या फिर उनकी कुछ सेट फ्रीक्वेंसी होती है लोडिंग टाइम और बर्निंग
uh,
टाइम?
as per the loading time उसको यूज किया जाता है,
तो मैम
फ्लक्चुएटिंग भी होते
कंटिन्यूअसली
हैं
रन नहीं होते?
हैं
कंटिन्यूअसली रन नहीं होते वो?
कॉन्टिन्यूसली फिलहाल तक जो अभी ये रिसर्च स्टेज में ये ज़्यादा यूज हुआ है, और मॉडर्न प्लांट में भी थोड़ा थोड़ा यूज हो रहा है, इतना ज़्यादा यूज नहीं हुआ है, अभी भी रिसर्च स्टेज में ही है। ठीक है।
ठीक है मैम।
Next one is the oil burners. So under this, we are having the vaporizing oil burners. So why the name is given vaporizing fuel oil burners. So the fuel will be vaporized before the ignition itself. So uh, in this case, the main function of the burner is that it will first vaporize the fuel before the ignition. Another one is in this case, it will properly mix the air with vaporized fuel. Okay. So in this case, the soot formation is less, and here it will provide a high heat release by burning the large quantity of the fuel. Okay, so in this case, we are having the atmospheric pressure atomizing burner, rotating curve burner, recirculation burner, and weak type burner. So, atmospheric pressure atomizing burner will be used for the highly volatile fuels such as naphtha and volatile gasoline. Mm, and then it is the rotating cup burners. So it will be used in low and medium capacity boiler. In this case, electric motor or an air turbine runs the mm, shaft and the cup at high speeds of around 3000 to 10,000 rpm. Recirculation burner, part of the combustion products are produced are used to preheat the incoming fuel and air. Wick type burner, a cotton or asbestos wick is used, which raises the liquid fuel by capillary action and it will vaporize at the entry point. Uh, it is suitable for models or domestic applications. Okay, so these are the four types of vaporizing oil burners. Then we are having the atomizing fuel burners. So as the name is given atomizing, so here we will use a mechanical system or oil pressurizing unit like your injector. So atomized means that the droplet size should be at the perfect size so that it can mix with the hot air so that it will properly vaporize and the proper flame uh, can be formed. Okay, so here you are using the mechanical or oil pressure atomizing burners, or we can say the atomizer or injector air resistor diffuser burners throat opening are used. Steam or high pressure air atomizing burners are also available. Steam is used for atomization of air. So low pressure air atomizing burners are used. In this case, the pressure is about 0.015 bar to 0.15 bar air pressure. Okay. So with the pressure of the air, that oil will be atomized. Okay. So I'm not going to the details of these oil burners. So just I'm giving you the overall idea of how it works and what are the type. Okay. Then we are going to discuss the steam burners. So as it is a steam power plant, so first we need to discuss what are the steam boilers are available, and then we will discuss the steam turbine, and then we will discuss the condenser types, and then FD fan and ID fan, which are used at the boil furnace as well as in case of the chimney. Okay, so individual components now we are going to discuss. So in case of the steam boilers are also known as a steam generator, is usually a closed vessel made up of the steel. Its function is to transfer the heat produced by the combustion of fuel, that is the solid or liquid or gaseous fuel, to the water and ultimately to generate the steam. So in this case, volume of water will increase uh, approximately about 1600 times after conversion to the steam. So as I have already told you, there are the different types of different application of the steam. So one is the generation of the power, another is the process industries like your textile industries for sieving and bleaching, etc., and many other industries like sugar mills and chemical industries. And third is your for producing the hot air for the large building, hot water for the last building, so the which can be used for heating installation at much lower pressures. Okay, so these are the applications of the steam which are generated from the steam boilers. So then the important terms associated with the steam boilers are boiler cells, then combustion chamber, grate, furnace, heating surface, mountings, and accessories. Okay, so the boiler cell means it is a closed vessels inside which the combustion of fuel will occur. Also, the generation of the steam will be there. Okay, so that is your boiler cell. Mostly, these are made up of the steel and it is riveted. So it is different steel plates are considered, so which are riveted at the different points, or it is welded as per the working pressure. Okay, so then we are having the combustion chamber. So combustion chamber is mostly it is related to the furnace. So in the combustion chamber, the hot side will be the insulated with the help of the bricks, so that whatever the heat is generated, that should not escape from the chamber. So inside this combustion chamber, we will have the grate. Okay, wait for 5 minutes. So uh, please wait me for the 5 minutes. Satya. Okay, sorry for the disturbance. So combustion chamber, inside this combustion chamber, we will have the grate over which the solid fuel, that is your coal, will burn. So that coal will be supplied, either it is a powder form, or it is a different size. Okay. So this is the furnace. So furnace is inside which that fuel will burn. Burn. Okay. Then a heating surface, there is a heating surface like tubes are used through which the heat exchange will be there with the water and flue gas. Mountings. Mountings are used for the proper functioning of the boiler. And these are the essential thing for the boiler, for the safety aspects of point, and for the other aspects. So that is your measurement of water level, or feed water amount. Okay. So under these mountings, we will have the pressure gauge, which will measure the working pressure of the boiler. So if it is more pressure is generated, then that pressure will be released with the help of the safety valves. We will have the water level indicator to know the level of water inside the boiler. We will have the water level indicator. So if it is the level is low, then it will be supplied with the help of the pump from the feed water. So these are the different mountings. Steam stop valves are also available, and um, many things are available which will be discussed in later session. Then we are having the accessories. These are not the essential part. This can be used to improve the efficiency of the boiler. One is your feed pump, another one is the economizer, superheater, air preheater, steam separator. Already I have discussed with the individual function of this equipment. So in detail we will discuss in next section. Okay, so this boiler can be designed as per the American SME standard, that is your American Society of Mechanical Engineering. Okay, so it will be made as per the standards of the boilers, which are listed. Um, in as by the society. Okay, so then we are having the classification of the boilers. So already you have idea. In the last semester, we have uh, certain knowledge about these boilers. So first one is the horizontal and vertical and inclined boiler. As per the boiler axis, the name is given horizontal boiler, vertical boiler, and inclined boiler. Then we are having the fire tube boiler and water tube boiler. Fire tube boiler means inside the tube there will be the supply of the flue gases. Outside of the tube, that is the uh, supply of the water. The examples are Cochrane boiler, Lancashire boiler, locomotive boilers. Then we are having the water tube boiler, Babcock and Wilcox boiler, Stirling boiler, externally fired and internally fired boiler. Externally fired means in this case the fire is outside the cell. That means it is not inside the boiler cell. So that is an externally fired boiler. The example is your Babcock and Wilcox boiler. Internally fired boilers means in this case the firing is done inside the boiler itself. That means the furnace will be present inside the boiler cell. The example of the internally fired boilers are your Cochrane boiler. Okay, then we are having the forced circulation and natural circulation. So the forced circulation means in this case the circulation of the water will be done by the help of the forced pump. So example of the forced circulations boiler are Velux Velux boiler, Lamont boiler. So these are the high pressure boiler, or sometimes these are also known as the critical boiler. So high pressure boiler means in that case the pressure will above the 80 bar. If you have remembered, so that is the high pressure boiler. Low pressure boilers means in that case the boiler pressure is less than this working pressure. Okay, so in natural circulation boiler, we will have the natural that water will move upward with the help of the natural current or convection current, which will be generated by the uh, application of the heat. Okay, so natural car circulation examples, natural circulation boiler examples are your Babcock Wilcox boiler, Lancashire boiler with and Cochrane boiler. So these are the natural circulation. Then high pressure boiler and low pressure boiler. Already I have explained just now. Stationary and portable boiler. So stationary means it is fixed in the industries itself. So that is your stationary boiler. Portable boiler means it can be carried to the different places. So locomotive boilers are examples of your portable boilers. So next one is the single tube boiler and multi-tube boilers. As per the presence of number of tube, the boiler is classified as a single tube and multi-tube boilers. Okay. So next one is the okay. Now we are going to discuss the different fire tube boilers. So first one is a simple vertical boiler. So simple vertical boilers means in this case one tube will be there. Okay, outside of this tube there will be the supply of the water, and inside which there will be the supply of the flue gases. Okay, so below this one there will be the presence of the furnace. So this is the simple vertical boiler. The tube of the boiler is the vertical. In this case, rate of production is not exceed the 2500 kg per hour, and pressure is normally limited to the 7.5 to 10 bar. So this is the working pressure. So next one is the Cochrane boiler. So Cochrane boilers already you know, that one we have discussed in thermodynamics lab. So Cochrane boiler means it is one of the best types of vertical multitubular boiler and has number of horizontal boilers. So there, if you are observed, there is the number of horizontal boiler. One side is there will be the supply of the flue gas, another side it is connected to the chimney, right? And it is circulated with the help of the water. Okay. In this case, the number of tubes in this case will be about 165. 165 tubes can be used. Okay, so in this case, you will have the working pressure is maximum 15 bar. Maximum is 15 bar. This is the working pressure. Okay, so here you will get the efficiency of the boiler is 70 to 75 percentage. So I'm not writing in detail. You can understand by this small note. Then we are having the cornice boiler. Cornice boiler means in this case number of tubes will be one adopted in the time of introduction of the high pressure steam to the early cornice engine and still used. Okay, so in this case number of flue tubes will be one. Okay, and here the working pressure steam will be about 10.5 bar. It is the maximum. Okay. So this is the Cornish boiler. Then we are having the Lancashire boiler. So these are commonly used in sugar mills and textile industries, mostly used in the process industry, you can say. We are along with the power, steam, and steam for the process work is also needed. Used where larger reserve of water and steam are needed. Reliable. It is reliable, simplicity in design, ease of operation. Okay. Then we are having the locomotive boilers. So locomotive boilers are mainly employed in locomotives. It is of the compact size. The capacity to steam production is quite high for its size. It can raise large quantity of steam rapidly. Then we are having the Scotch boilers. The Scotch boiler, it is the Scotch type of marine boiler, can be produce steam capacity of about 1000 kg per hour, and working pressure is about your 17 bar. So it is of the compact size and occupies small floor area. So it is used mainly in case of the ship. Okay. So this is all about your different types of factory boilers. In locomotive boiler, the working pressure is about your 14 bar. Okay, so I'm not discussed it detail. I have not discussed it in detail. The common example of yeah, fire tube boiler is the Cochrane boiler. So this one already we know. I'm not explaining it. Okay. So then we are having the vacuum filled cup boiler. So here it is the water tube boiler. So in this case, the furnace is placed outside. It is the upper header and this is the downtake header. So at the downtake header, water will be supplied through this tube, and it that will move towards the uptake header at the upper end, and the steam will be generated by exchanging the heat with the flue gases. Okay, there we are having the separator. Sorry, superheater tubes. So these are the superheater tubes. So where at the top it will be generated as the superheated steam. So these are the different mounting pressure gauge, water level indicator, feed check valve, and your steam stop valve, anti-priming pipe, safety valve. Okay, so these are the um, mounting and accessories is your superheater. ओके, सो ये भी एक्सप्लेन नहीं करेंगे क्योंकि ऑलरेडी आप लोग जानते हैं. सो बैबकॉक वेलकॉक्स का बॉयलर का जनरेटिंग कैपेसिटी है, हीट जनरेशन कैपेसिटी है 2000 to 40,000 kg per hour. So it is also a multi-tube boiler. Okay, so these are the different advantages and disadvantages. So then we will discuss the high pressure boiler in the next class. So after completing this high pressure chapter, I will share this slide to you all. Okay, steam turbines. So I have mentioned a few things only, but while discussing in detail, I will explain the what is the details of this compounding. Okay. So tomorrow I will explain the high pressure boilers. Thank you all.
Thank you, ma'am.
Ritika,
Thank you,
Thank you,
ma'am.
ma'am.
Ritika,
Thank you,
Thank you,
ma'am.
ma'am.
welcome. Okay, so I'll take the attendance or what? You are having the class at 9:30, so I'm not going to take your attendance. Ritika,
Yes, ma'am.
now only 74 students are available. So उनका ही attendance मुझे दीजिएगा.
Okay, ma'am. I'll
मैम
send attendance accordingly.
मैम
Oh, बोलो.
मैम
हाँ,
वो पीडीएफ सेंड कर दीजिए मैम जो आप पढ़ा रहे हैं.
ठीक है, मैं सेंड कर लूँगी. ठीक है,
यस मैम.
अभी सेंड कर लेती हूँ.
Thank you, ma'am.
ओके,
Thank you, ma'am.
वेलकम.
थैंक यू मैम.